Hey, happy Tuesday, everybody. So this is going to be the next video, which actually be a lot shorter, this video, because what I would like you to do is to run a little experiment with the program that we created from last class. So this was basically set up to be a Poggle activity, but unfortunately we are not Poggling. So if you want to work on, if you know somebody in your class and you want to work with them on this, I have no problems with that. You will need to submit your own assignment though, but if you want to work together, that's totally fine. But again, you'll have to basically do it separately if you don't. So anyway, as you can see, with the purpose of this is to determine whether if the random number generator that is within App Inventor is actually a really good example of pure randomness. And what you want to do whenever you have a random number generator, you want it to be completely unbiased. And by that I mean you don't want to have it skewed to either heads or to tails. You want to make sure that it is as close to 50-50 as possible, a non-biased random number generator. And the reality is that eventually randomness does occur. It could be maybe trillion or quadrillion or even beyond numbers down the line. But what you want to do is you want to prevent a repetitive pattern from forming, because once a repetitive pattern forms, it then becomes very easy to then determine what the next value is going to be. So by having something that is completely random is great, because then you know that the number that's being generated is purely just a random coincidence. So what we have over here is an example. You can read through this and you can kind of see what it's saying, but this is an example of what it would look like. So we created a table. If you want to create your own table, you're more than welcome to. I created one so that you can use the one that I have as well. I created through a Google Sheet, which I'll show you in a minute. But all I want you to do is to run 20 trials of the program that we created. And again, the number of flips, how many flips you're going to perform. And then what you want to do is you want to record the number of heads that have come up every single flip. So this will then convert it into a percentage, yielding a total of 100 flips, yielding 45 heads, yielding the total percentage. Well, now trial 2 comes around. We're going to flip it the same amount of time. And you want to flip the same amount of time every single time. You don't want to edit this 101 time, 1,000 another time, and so on and so forth. It's got to be the same number every time. But on the second trial, heads came up 51 times, yielding 51%. Now, as you're seeing, this is now accumulative. So trial 1, 100 flips, and trial 2, 100 flips are now added together to give us 200 flips. The number of heads, 45 and 51, have been added together, and this is completely wrong because this should say 96, not 93. And then that would then yield the total heads percentage. All right, and then so on and so forth. And so that problem is going to just keep going, on and on and on. So that is what I want you to basically do. And so let me go over to the Google Sheet and explain this. So I put this together for you. This is in read-only. This link for this is within the assignment and in the notes area. So all you have to do is click on the link. It'll take you here. All you'll then need to do is just make a copy of it, so that once you make a copy for yourself into your Google Drive, all right, you'll be able to then edit this to however you want. But this is what I'm talking about over here, where the only 2 columns that you need to adjust are these columns B and C over here. All right, you don't need to do anything else. All of these are basically have, as you can see down here, have calculations already set for you. So all of these things you don't want to mess with, or you don't want to change, because if you do change it, you're going to ruin the calculation. All right, same way with down here. So all you have to do is again, how many number of flips you're doing. Again, remember that all 20 trials have to be the same amount. I don't want you to do 100. I want you to do a little bit more than that. What if you run with 500 or 1,000 or 2,000 or 5,000 or 10,000 or whatever? But it's got to be consistent every single time. Remember that the bigger the number we go, the slower it'll be to complete the flips. though 1,000 or 10,000 flips shouldn't take, nothing more than a mere few seconds. Record the number of heads you have, all right? And then as you go through every single trial, all right, you're going to see all these values, changing as well as down here as well. All right, and so ultimately what we want to determine is how close to 50% are we getting with the number of heads that are being flipped with 20 trials under our belt. Because remember, 1, 2, or 3 trials isn't enough. When we do a large sample size of 20 trials, that's going to get us a lot closer to a more accurate representation of how this random number generator works. And now what we need to do is we need to retrofit our code slightly. So what we see over here is I already created the code, and I'll explain what it means. But the rest of the stuff from here down into here is the code that we've already created from last Thursday. That's our random number generator for coin flip code. Now what I want you to do with this is to add a little bit of extra coding to it. So the first thing to make sense of, we have our conditional statement, our if statement. So we want to check a condition to see if something equals something. And connected into that, we have this green rectangular block over here, which we could find in our logic area. And we have our AND block right over here. So you're going to pull this out, and you're going to plug this into my if-then statement. And the reason why we're using this block of code, specifically the AND block, because if you remember when we talked about binary code and we talked about logic gates, 2 units ago, we talked about the AND gates and the OR gates. Well, these things work in similar fashion. In order to have an AND gate, that means condition 1, which is this over here, and condition 2 have to hold true. If they both hold true, then we're going to execute or do the code that is located within this if block here. If one of these or both of these fail and they do not pass, well, then we don't do any of the code in here. And as you notice, we don't have an else block here. You can use that if you want, and I'll explain in a little bit. But for now, all I'm going to use is the if block. So if one of or both of these do not pass, then I'm just going to ignore everything that's in here. So what am I going to put in here? Well, what I'm going to do is I'm going to grab all of this code and I'm going to pull it out. Now, what I need to do is I need to have this set global n textbox.text. I need that to be the first line of code here. So I want to break these two up, and I'm going to grab this one, and I'm going to plug it back into here, and I'll explain that in a second why. What I'm then going to do is I'm going to take the rest of this code, and I'm going to click, and I'm going to drag and drop it into my if block here. And then what I'm going to do is I'm going to take this if block, and now I'm going to plug it back into this button coin.click below the set global n variable. All right, so let's make sense of some of this and why did I choose to connect the way I did. Well, starting with this if block here, what are we checking? Well, the first thing we're going to do, we're going to check, is the variable that's being stored within global n, is it a number? So where am I finding this? So if I go into my math tab here and if I scroll toward the bottom, all right, we have a block of code here, is number. And if I mouse over it, it'll tell us a little bit of information on it. All right, test if something is a number. And as you could probably just even guess, is number. I mean, that's basically what it's doing. So again, if I go into my designer side here, this was my text field here, which we said was the value n. And what I am doing specifically is I am checking to see if the information that's being typed in this text field here, right, is it letters, or is it some symbols, or is it truly a value of numbers? And I do not want symbols, I do not want letters, I only want numbers. Because, I mean, how can you really kind of count 1 through whatever value when you're using letters or symbols? I mean, it's not going to work. And so the computer system is not going to know how to process that. So, you know, what we want to make sure is that if I want to run with 10,000, I type in 10,000, I hit flip coin, it's going to flip the coin 10,000 times. If I type in the word tree and I hit flip coin, well, what does that mean? All right, so the computer system, you know, would probably crash, or the program would probably crash, or it might even just ignore it. Sometimes, depending on what you add, could potentially get stuck in an infinite loop, which you do not want. So we want to make sure that we're only limiting to numbers that are in here, so that if somebody typed in anything other than a number, well, then this condition would fail. And that means this whole thing would fail, which means you would never, ever execute what's within this if block here. Also, what I want to do is I want to get the value that's currently stored in global n, and I want to see if it is less than or equal to 100,000. And so I want to limit the ceiling of the number at 100,000, because anything beyond that, you're getting quite large in number, and it will take a very long time for the flips to kind of count from 1 all the way up to 1 million, 10 million, a billion, a trillion, and so on and so forth. And then you can get, not that your computer program will be stuck in an infinite loop, but it will just take minutes, if not hours, to complete all the coin flips. And you don't want to tie your phone up for that long. All right, so that is the meaning of why we're using this code, this new code here. And again, we're checking if this condition, if it's only a number, and if we're less than 1,000, then we're going to execute, set the value for n heads to be 0, and then we're going to then utilize the loop to then do all the coin flipping, and we're setting global coin equal to 1, and then setting n heads to n heads plus 1, that's for the counter, to increase the loop over here to get the number of how many times I need to flip, and then showing the results within the field of heads versus tails. And remember, on the spreadsheet, we're only concerned with recording heads, and obviously we can assume what tails would be if we know what heads is. The last thing is that I said I'm keeping this separated and keeping this out here. And again, hopefully it was apparent, but if not, the reason why I'm keeping that separate above this if block here is because I need to know what number is being typed in here. So if I type in 100, all right, I need to then set that global n to 100. If I had this variable here inside this if block, well then every single time, since I'm initializing global n to 0, it's always going to be putting the value 0 in here. So it's always going to pass this criteria, regardless of if you're typing in letters or symbols or whatever. So I need to make sure that this text box.text is on the outside, because whatever I type in here, all right, it needs to now pass into here to do the conditional check to see if whatever I'm searching on or whatever I'm doing is what it's supposed to be. So if I type in 1,000, 1,000 is called. Yes, it is a number, and 1,000 is less than 100,000, so therefore everything is true. I then go into the following block here and I do what I need to do. All right, so that is what you need to know about the retrofit of the code. And like I said, we're going to utilize our spreadsheet here to then run 20 experiments, and calculate or tabulating the number of flips and the number of heads that have come up every single time. Remember to use more than 100. I would say at least use 1,000, but definitely keep it under 100,000. But again, you don't have to use increments of base 10. You can use 4,500 if you want, but it just has to be the same every single time. You can use 575, but it has to be the same. I would say probably to keep it, use an even number rather than like 575 being an odd number. Use an even number so that you have the potential to have the a 50-50 amount of heads versus tails. But again, whatever even number you want to use, feel free to use. Just keep it the same all the way down. And lastly, when you are done with recording all the results that you get from here, all right, and if you want to create your own table, it's up to you, totally fine. If you want to use the one that I generated, remember you have to just copy that into your own Google Drive and then adjust that. And then lastly, you want to answer the 2 questions separately that are down below. And again, you can do them on a separate piece of paper. What I would say is for turning in the assignment, I would probably say just do screen grabs. Do a screenshot of or take a picture of your work and then just submit the screenshots. It's more efficient and quicker for me to kind of just do a quick preview on the screenshot to look over the data in the Google Doc, the Google Sheet table, as well as the answers to the questions here. And I'll be able to kind of just go through that, read quickly, and then determine accurate, how accurate everything is or whatever. Versus just submitting me the file and then having to go through the file, open it, and extra loading time or whatever. So it just takes a little bit longer for that. So just do a quick screen grab for both these questions right here, as well as this data table right here, and that should be it. And then you can submit that, and then you'll be good to go. So what I will do is I will wrap up the video now. If you have any questions, please reach out to me. Let me know. And if you think you're in good shape, then just crank it out, and then we will talk to you on Thursday. On Thursday, we will have another video that I will post online that will be covering the PRNG, the pseudo random number generation in App Inventor, and we'll actually look at the modulo operators and how the randomness is actually calculated within App Inventor, and we'll explain that entire process. All right, so that is it. So if you have any questions, let me know. If not, have a fantastic day, folks. We will catch you on Thursday. Take care.